In this video, we're going to be looking at composition of functions. So if we have the functions f, g, and k defined here, let's see if we can find out what these compositions are. Okay, so the first one that we have here is f composed with g evaluated at 12. So it's going to be the first one evaluated at the second one, evaluated at 12. Now, what is g of 12? Well, we just come back here for the formula for g, and anywhere there's an x, we replace it with a 12. So 7 times 12 is 84. 84 minus 3 is 81. And we have that. So I come back to here, and that's going to be f evaluated at 9. And f evaluated at 9, well, I'm going to take the formula for f, and everywhere there's an x in it, I'm going to replace it with a 9. And so that's going to be 3 times 81 minus 36 minus 1, and that'll get me 206. So that's my answer for that one. Now, what if I reverse it? G composed with f evaluated at 12. It's going to be the first one, evaluated at the second one. Now, what is f evaluated at 12? Well, everywhere there's an x in there, I'm going to replace it in the formula for f with 12. So that's going to be 3 times 12 squared, so 3 times 144, minus 4 times 12, so minus 48, minus 1, and that gives us 383. And so that's going to go in there. And so that's going to become g evaluated at 383. Now, what's g evaluated at 383? Well, wherever there's an x in my formula for g, I'm going to replace it with 383. And 7 times 383, and then minus 3 gives me 2678. And I cannot simplify that any further because 2678 is 3 times 103 divided 3 times 13 times 103. So I can't break that down or simplify it anymore. So that's the exact answer, square root of 2678. Okay. All right. Now, what if we get to k composed with g evaluated at 12? All right. So it's going to be the first one evaluated at the second one. And so now I need to find out what g of 12 is. Again, it's going to be, well, I replace the x with a 12, okay? And that's going to be the square root of 81 is what's inside there, which is 9. So this will be k evaluated at 9. And what is k evaluated at 9? Now I come to the formula for k, and that's going to be, everywhere there's an x, I replace it with a 9. Okay, and so I'm going to get 14 in the numerator, and I'm going to get 9 minus 7 is 2 in the denominator, and 14 divided by 2 is 7. And so my answer is 7. All right, now notice we don't have a number here. It's x, so we're going to get a function. So an expression with x's in it. So what is f composed with g of x? Well, when it's written in this order, it's going to be the first one evaluated at the second one. Okay. It's going to be the first one evaluated at, well, I have a formula for g of x. It's the square root of 7x minus 3. And so now what is f evaluated at 7x minus 3? Well, I'm going to rewrite the formula for f. I'm going to put blank parentheses wherever the x is. And now what goes inside those blank parentheses is going to be square root of 7x minus 3. Now, this is a correct answer. The way I've written it is a correct answer, but if it's a multiple choice final exam problem, you're going to have to simplify it if it can be simplified. And if we look at this, this square undoes this square root. So what I've circled there is just going to be 7x minus 3. So if you take the square root and square it, you just get what's inside the argument there. Now, 4 cannot be multiplied through this square root. It's got to stay on the outside. And now I just need to clean this up. So I'm going to have 21x minus 9 minus 4 times square root of 7x minus 3 minus 1. And then I can put those together. So that gives me minus 10. Okay, so that's my final answer. I cannot simplify that anymore. So I get a function. I don't get a number. Now, quick way to check if I did this correctly is we found f composed with g evaluated at 12 the direct way. Also, if this formula is correct, I can plug 12 into it and I should get the same answer. And that would be 21 times 12. So everywhere there's an x, I'm going to replace it with 12. Okay, so 21 times 12, oops, is 252 minus 10 minus 4 times, that's going to be 81, and the square root of 81 is 9. So I'm going to have 252 minus 10 minus 36. So 242 minus 36 is 206. And notice that that is consistent with that. Okay, so that's what we expect. That's a good way to check if you answer's right. And the last thing I have to do is k evaluated with itself. Let's see what that's going to give us. So k evaluated with itself is going to be the first one, evaluated at the second one. Okay. So I'm going to have k evaluated at, well, what is the rule for k? It's x plus 5 over x minus 7. So k evaluated at, well, I'm going to take the rule for k and I'm going to write it without any x's, just blank parentheses. Because what do we want? We want that to go in where the blank parentheses are. Now, again, what I have written here is correct. This is a correct answer. However, you have to simplify it, and this can be simplified. We need to have a simple fraction, not a complex fraction. And so I'm going to multiply this by 1. And how am I going to choose 1? Well, the denominator here is x minus 7. So I'm going to multiply that by 1. And I'm going to write 1 as x minus 7 over x minus 7. And so what am I going to get? Well, when I multiply x minus 7 times that fraction, the x minus 7s are going to cancel and get x plus 5. And then I'm going to have plus 5 times x minus 7. Make sure that you put it in parentheses. And then here, when I multiply x minus 7 through to that, they cancel, and I'm left with x plus 5. And then I have minus 7 times x minus 7. Make sure you put it in parentheses. And so I'm going to get x plus 5, then plus 5x, minus 35 in the numerator. And the denominator, I'm going to get x plus 5 minus 7x, and then plus 49. And then I have to clean that up. X plus 5x is 6x. And 5 minus 35 is minus 30. X minus 7x is minus 6x. And 5 plus 49 is 54. And I can simplify this. I can factor out a 6 in the numerator, and I can factor out a negative 6 in the denominator. And 54 divided by negative 6 is negative 9. And if I multiply the 6's back through, I should get back to that. So my final answer is going to be the negative of x minus 5 over x minus 9. And so that completes the negative of x minus 5 all over x minus 9. And so that's everything that we wanted to go through in this video. And just email me if you have any questions.